So, welcome back. So, this lectures is deal with the digitization and recording. What I will discuss before you go to the any speech or this kind of things, you should familiar how to record the speech. Many people know that how to record the speech, but at least some you can say the skill kind of things I will explain here, not details of digitization, details of this, that kind of things are not clear, but okay, some what do you mean by digitization or kind of things I should explain. So, if you see the normal human hearing is 20 Hz to 20 kilohertz, you know that, and human speech is 50 Hz to 800 or 8 kilohertz, and standard phone circuits or telephone speech is 300 Hz to 3 kilohertz or 3.3 kilohertz, sometimes say 3.3 kilohertz. Okay. So, this is the bandwidth of the human speech, normal human speech 20 Hz to 20 kilohertz. Okay. Now, what I want that I want the digitization of the speech. What I said that speech is in acoustic speech, whatever the human being is produced, that human speech is in acoustic wave. So, once the human being produce the speech to do any kind of speech processing, I should have to digitize the speech, because we said the digital speech processing. So, I say something, I have to convert it that acoustic wave to digital speech domain. First analog signal, then analog to digital conversion. So, what do we do that? We use a microphone and amplifier, and then microphone amplifier, then analog to digital conversion to convert the acoustic wave to a digital signal in this speech. So, how do you do that? You know that this is the basic theory. This is called sampling theory, that sampling frequency, this is the complete circuits, that this is the normal DSP systems. So, I can say analog speech, I am not details with the details of this every blocks. So, those are the signal processing domain, but you should know what is there in computer. So, there is a analog speech which is coming from the microphone, may be converted to the going to the anti-aliasing filter, then sampling hold, then ADC, analog to digital conversion, then we do the required signal processing. Then again, if I say the human listeners cannot listen that electrical signal, again I have to convert that electrical or digital signal to analog signal, and analog signal should be played in a loudspeaker to produce the acoustic wave. Now, so sampling frequency, analog to digital conversion, sampling frequency is one of the important issue. So, basically what it is that maybe some of you are there who do not know the digital signal processing or analog to digital conversion. So, just I explain the very briefly that one. So, let us XAT is a time domain signal. What do you mean by time domain signal? Here is the time and here is the amplitude. So, the signal is varying like this way. So, that is the time domain representation of the signal, analog signal. So, the analog signal is continuous. If you see, it is a continuous signal. Okay. Now, I want to convert this signal to a digital signal which is xn. Okay. I convert this same signal to a analog digital signal which is xn. Instead of xt, I convert to xn number. What is nothing but a, so digital signal is nothing but an integer number. So, how do I do it? First, there is a time which is continuous. I have to convert this time to a some instant with a fixed interval, that is delta t. It is a fixed interval delta t. So, I can say that I am taking the XAT as a sample, or I can think about a switch, that suppose this is a switching circuits, there is a XAT is going on, I am closing the switch with a frequency with the duration of delta t. So, for this delta t I take the signal, then again I have take the signal here, I take the signal in here, I take the signal in here, take the signal in here. So, what I am doing, I am converting the continuous t with a nt with a duration of delta t. So, n delta t. So, n 0 that means here, 1 means here, 2 means here, 3 means here, 4 means here, 5 means here. Okay. So, if I think about the frequency representation of this delta t, 1 by delta t is the frequency. What is the frequency of operation of this switch? With the frequency is 1 by delta t. So, which is nothing but a called Fs, sampling frequency, Fs. So, sampling theorem, if you see, if there is a sampling theorem, this is the sampling theorem which is explained in this slide, I am not saying again and again. So, I can say, if the sampling theorem say that it is possible to completely recover this signal from this sampled signal, there is a some rider or some constraint. What is those constant? It constant says that if the baseband frequency of this signal is bandwidth is B, baseband, or you can say the bandwidth is B means let us the highest frequency component of this signal is Fm. If I sample this signal which is Fs, which must be greater than or equal to 2 Fm. This is the rider. It is possible to recover the signal if it is greater than or equal to twice Fm. Why it is greater than or not all time equal to? Because let us think about a pure sinusoidal wave. If it is a pure sinusoidal wave, if it is 2f, if Fm is equal to Fs is equal to 2 Fm, then all the sample will be here. So, I cannot recover the signal. So, in that case, I require Fs must be greater than twice Fm. Okay. So, instead of taking the analog signal, so on the operation on the analog signal, I am taking some sample instant. That is called that. How do you take the sample instant? Multiplying this signal with the sampling frequency impulse signal whose frequency is Fs. So, when I can say the impulse is there, when the impulse is present, I take the measurement of the signal, that is Fs. Now, if you see, if my Fs is increases, this gap will be decreases, delta S, delta T will be decreases. If Fs is increases, delta T will be decreases. So, if I use the, if my sampling frequency is much larger, then I can get accurately the signal. Okay. But rider, I cannot lowest, the rider is that Fs must be greater than equal to 2 Fm. Okay. But I can take any sampling frequency. So, let us, human speech has a 20 hertz to 20 kilohertz. I can take the sampling frequency, let us 44 kilohertz. I can take it, which is much above the 2 times of the, which is much above the 2 times of the 20 kilohertz, 40 kilohertz, 44 kilohertz I have taken. Okay. Now, if I increase the sampling frequency, I said that I can accurately take the signal. Okay. Now, sometime you see, although human speech is 20 hertz to 20 kilohertz, we have taken a sampling frequency let 16 kilohertz. What is meaning? Meaning is that I am restricted the speech signal, but I am interested the speech signal. So, if it is 20 kilohertz is sampling frequency, so highest frequency of the speech signal is 8 kilohertz. So, human speech has to be passed to a filter whose highest cutoff frequency is low pass filter is 8 kilohertz. Up to above 8 kilohertz, all frequency has got down to 0, or you can say discard all those frequencies. So, sampling frequency, based on the sampling frequency, you know up to what frequency I can get of this speech signal. Okay. So, that is the sampling frequency idea. So, in speech sometime we use 16 kilohertz, that means highest frequency component of the signal is 8 kilohertz. If it is 22 kilohertz, then it is 11 kilohertz. Okay. So, that is called sampling frequency. Other aspect is quantization. So, quantization is again I have to, what I said, I take a instant of this value. This is nothing but a voltage. If it is amplitude, it is voltage. Let us pass 5 volt, minus 5 volt is here. So, this voltage has to be converted to a some step. If you see here, some step. So, each step I can represent by a binary number. If a computer is represented by binary number, so I can say, okay, let's that my minus 5 volt to plus 5 volt, or I can neatly draw it so that you can understand it, that let us I have a signal which varies from minus 5 volt to, let us this is minus plus 5 volt and this is minus 5 volt. Okay. So, this whole 10 volt I divided into a some level, some level. So, how do we decide the level? Let us, this whole 10 volt is divided in, or you can say that I am representing this 10 volt by a 8 bit number. So, what is the highest value of 2 to the power 8? 8 bit number means integer value is 2 to the power 8. So, 2 to the power 8 is 256. If it is negative and positive, so 1 bit is goes for sign. So, it is minus 127 to plus 127, or including 0 it will be 120. So, I am not saying that part. So, making 0 is middle, positive and negative. Understand? 250, sorry, minus 127 or 126, you can take it. So, 8 bit number. So, now if I do that, then 250, I have divided this 10 volt in 256 level. Okay. So, plus side and minus side is there. Okay. I can divide this thing instead of 8 bit, 16 bit. So, 2 to the power 16 level I can divide this thing. So, once I divided this signal much more smaller gap, the accuracy of the quantization will be increases or quantization error will be decreases. I am not detailed discussing about the quantization error, because that is there, quantization error. So, what I am saying, that if I recorded the speech signal with a high quantization, the accuracy or error, quantization error of the signal is reduced. So, when I am going for a good quality recording, I should use quantization level should be very high. Instead of 8 bit, if I use 12 bit or 16 bit, the quantization error is less. But other aspects is there. What is other aspects? Once I increase the quantization level, what is increasing? Data size. Because if it is 8 bit, one sample is represented by 8 bit. If it is 16 bit, single sample is represented by a 16 bit. Similarly, Fs, if it is 8 kilohertz, I can say in 1 second I have generated 8k sample. In 1 second I have generated 8k sample. If each sample is represented by 8 bit, so for 1 second speech recording I will get 8 kilobyte. 8 bit is 1 byte, so 8 kilobyte. Similarly, if I quantize it with 16 bit, it will be 16 kilobyte. 16 bit is 2 byte, so 16 kilobyte. So, one I increase the quantization level, although my signal to noise ratio decreases, means increases, that means quantization error is decreases, but my memory size is increases. Similarly, once I increase the sampling frequency, my accuracy of the digital signal will be increases, but what is increases? Size of the file is increases. Instead of 8k, if it is 16k, that means in 1 second I have generated 16k sample. If each sample is 8 bit, then 16 kilobyte. So, there is a trade off, what quantization level I should use, what kind of sampling frequency I should use. So, when you record the speech signal, suppose you are recording the speech signal for telephone speech, which is bandwidth is 300 hertz to 3.3 kilohertz. So, if it is my signal is band limited to 3.3 kilohertz, I should not sample this signal with a very high frequency, high sampling frequency. So, my 8 kilohertz is sufficient, even if double this thing, nearest is 8 kilohertz is sufficient to sample this thing. So, that is why the telephone bandwidth is 4, if it 8 kilohertz is sampling frequency, 4 kilohertz is the maximum frequency which can present in the speech. Okay. So, now I give a problem. I am not going details of this digitization things. This is the problem. An audio signal is recorded using the following format. To store 50 millisecond signal in PCM WAV format, how much memory is required? Sampling frequency is 8 kilohertz, encoded with 16 bit and recorded in mono channel. So, if it is 8 kilohertz 8 bit, in 1 second it will generate 8K sample. So, in 50 millisecond, I have to know how much sample it will be generated, and for each sample is 1 byte, how much memory is required I can calculate. Okay. Similarly, there is another conversion also I should taught in here. Suppose sometime we said number of sample to time conversion is very important. Suppose I have a speech signal, I say a speech signal is sampling frequency is 16 kilohertz. Okay. How much sample will be there within a 20 millisecond signal? So, in 1 second there will be a 16 kilo sample. In 20 millisecond, in 1 second into 20, 320 sample. So, 320 sample represent 20 millisecond. If it is 8 kilohertz, then how many sample will be there? Half of this. Okay, half of this, because it is half of this. If it is 44 kilohertz, then you can calculate how many samples will be there. So, instead of 20 second, I can say 30 second. So, once I say the window size of 40 millisecond, then you know how much sample will be there. Similarly, if I say if 320 samples I have taken, time domain representation is 20 millisecond, I can convert. Okay. This will be frequently used in speech processing, number of sample to time, time to sample. Okay. So, this is the basic idea of digitization of the speech. Now, there is expertise required. How do I record the speech? Normal recording is that if you see I have connected, if you see I have a collar mic connected to a since it is wireless mic connected to a wireless transmitter, and there is a sound card, and this is once I talk, this mic is converted to electrical signal. This electrical signal goes to the sound card, digitize the sound card is digitize the signal and recorded it. So, microphone, there is a amplifier if it is required, sometime microphone directly connected to the sound card which contain the amplifier, then digital recording device or which convert that analog signal to digital signal. Then if I want playback, so I require a speaker or headphone, this kind of things. Okay. So, in digital recording what it does? It is does the digitization and storing of the sound. So, digitization means it requires the sampling frequency and also number of quantization bit, and also stereo or mono, that I have not discussed details, but most cases in sound recording does in mono, since it is a single channel that I want to record the human voice. So, when you analyze your voice in computer, you should record the signal in mono format, not stereo format. It is not required because there is no two sources are there, single source is speaking, so it is mono is sufficient. Okay. Same things, that how this is stored in computer, there is a different kind of file format, mono versus stereo, that I said stereo means 2 channel, mono means single channel. Stereo sound I am not explaining details, there is a stereo sound, there is a 5.1 channel sound, there is a Dolby digital sound. So, Dolby digital is again in one format, It is not a sound, you can say that it is a sound recording. Dolby Digital is a sound, you can say the compression technique, or you can say the sound compression procedure. So, Dolby Digital is a format instead of you can say the it is just not stereo mono kind of things. Okay. So, either 5.1 channel sound you have heard, mono sound heard, stereo sound heard. Stereo means 2 channel, mono means single channel, 5.1 means 5.1 channel. So, I am not discussing that part, that is another course which is called audio system engineering, there I have discussed the mono and stereo kind of things. So, what kind of file format is there? If you see that there is a file format, a lot of file format you see, .wav, NSP, MP3, MP4, WMA, DSS, AU, etc. So, all are, some are coded speech format, some are non-coded, because it is just stored the sample. Okay. So, but if it is the MP3, it is a compressed. So, sound can be stored either compressed or without compressed. If I store the signal, let us that in 1 second it is generate 8 kilobyte, I can compress it and store it, and that is the compression technique. And when I want to play the sound, I will decompress the signal and play it in the web. Similarly, when I process the sound, I should extract the sound sample by sample. So, if it is a compressed format, stored in a compressed format, I have to decompress it and use the sample by sample for processing, and again I can compress it. Okay. Now, any audio compression or MP3, MPEG-4, WMA or WMA, DSS, there is a loss. If we compress the sound, I have lost some sound. So, I cannot recover those signals, those sound once I decompose it and process the sound sample by sample. So, if I want to store the just simple recording in sample by sample, use PCMA WAV format. So, there is a PCM WAV format header file, Microsoft PCMA WAV format header file. So, once I get the sound file .wav format, this is a binary file, it contains whole recording of the sound. Let us I guess this, there is a header. So, if you see this header, there is a different chunk position has different information. So, I have to know what is the sampling frequency of the sound and what is the encoded bit of the sound. If it is 16 bit, that means 2 byte represent 1 sample. If it is 8 bit, 8 bit represent 1 sample. If it is stereo, all channels are same. If it is mono, if it is stereo, there is 2 channel recording is there. If it is mono, single channel recording is there, and there also sampling frequency is important, because unless I do not know the sampling frequency, I cannot process it. Digital signal or this digital processing of this sound file is required a sampling frequency. So, sampling frequency also stored in this sampling rate, byte rate, block again, block size, chunk this, or those format details are given in the slides. So, digital format, uncompressed and compressed format, what I have expressed, and then I can go for the microphone selection. Suppose I want to record, I say you to record your name in your computer. So, how do you record it? You may use a headphone and connect it to the computer sound card, and you record the sound. Okay. But once the human being produce the speech, its range is 20 hertz to 20 kilohertz. The acoustics wave contain 20 hertz to 20 kilohertz sound. Once I put the microphone in the front of the mouth, so microphone has a limitation. Microphone has its own property, that it has to be convert this acoustic wave to an electrical signal. So, microphone may have a limitation. So, microphone may have a sensitivity, microphone may have a frequency response, microphone has a pickup pattern, all kinds of restrictions are there. Who know the details of microphone, you know that there is a lot of parameters of the microphones are there. So, if you see, I am recording a speech with a microphone whose frequency response is maybe 100 hertz to 10 kilohertz. So, I cannot get the acoustics wave after 10 kilohertz, may not be required in human speech, but I cannot get those speech after 10 kilohertz, because my microphone has a limitation. it can only record the signal, or it can only transfer the acoustic wave to electrical signal of 100 Hertz to 10 kilohertz. So, if I apply a 12 kilohertz signal acoustic wave, it may not produce any signal, it not produce any signal. So, I am not getting any information in the electrical wave. Once that electrical signal I get, I will pass through the digital card. Okay. So, selection of the microphone frequency response, microphone type, how to connect it, all are very important. So, which microphone I should use, it depends on what kind of application I want to develop. Suppose I want to develop a speech coding for telephone channel, then I should not use a very high end microphone whose frequency response is 20 kilohertz, because my signal is 4 kilohertz band limited. So, I can use 10 kilohertz sensitivity of the frequency response of the microphone is very good for recording that telephone bandwidth. Even 5 kilohertz microphone, sensitivity up to 5 kilohertz is sufficient for recorded the telephone channel signal. Now, suppose I want to develop a speech corpus for research purpose. If I want that this corpus only used for scientific research, if I want that should contain that whole human speech range of frequency, then I should use a very high end microphone whose frequency response may be 15 kilohertz or maybe 20 kilohertz. Okay. So, the microphone, then the amplifier is also there, amplifier frequency response also important. So, amplifier and microphone whole frequency response should be higher than the my desired what frequency I want to record that things. And there is a, if you know so there is a different kind of microphone, hand handle microphone, head mounted microphone, all things are there. So, all microphones have the advantage and disadvantage. I am not going details of the microphones. Then there is a carbon mic, piezoelectric mic, dynamic mic, condenser mic, ribbon mic. Every mic has his own frequency response, his own advantage and disadvantage. Then there is a connector is there. Then if you see the directivity, microphone has maybe omnidirectional, maybe bidirectional, maybe unidirectional, all kinds of directional means in which point microphone has a pickup. That means if I use this kind of microphone, if you see the omnidirectional, that means that microphone can pick up from any sound any direction. If it is a unidirectional, that can only pick up a sound from in one direction. That is represented in a polar plot. The slides are there. Okay. This is the frequency response example of a microphone. Then recording issue. Keep mic mouth distance relatively constant with and across recording session. Setting your recording level is very important. Suppose if you see there is a clipping, one very important issue I will show you in software. There is a clipping is very important issue during the recording, and maximum people, or you can say the maximum people say that when you record the signal is clipped. What do you mean by clipping? Now, suppose I have my ADC or volume of the recording volume which is control the ADC level. So, suppose this is 5 volt to minus 5 volt. Okay. This ADC can handle 5 volt to minus 5 volt. Now, if I amplify my sound 7 volt to minus 7 volt, so suppose 5 volt to minus 5 volt sound wave, sine wave, let sine wave, it is very like this. If my limitation is 5 volt, if I apply 7 volt, so what will happen? After 5 volt, it will be flat. So, after 5 volt, it will be flat response. So, what is if it is flat, what is happening? So, this portion I am not getting, I am getting a flat. So, if it is clipped, that means it developed a square wave there. So, original frequency component of this signal I cannot get it. I get the square wave content all the frequency content. So, this kind of recording, if you record the signal which is clipped, then if it is clipped then your whole recording purpose is gone. Okay. Your whole recording purpose is, because it is developed lot of sound frequency also. So, be sure the signal is not clipped, recording label is not clipped. Okay. And environmental noise is very important, and there is a free software tools for recording. There is a speech tools. I have used Cool Edit Pro, I have used Web Surfer, Prat, all you can use, any software you can use, or I can you just go to the Google and type Prat will be downloaded and store it. Now, what session I will go, what home task, or you can say what practice I can given, that use this recording procedure and record your name. Let us 5 times record your name in 5 times, so that the signal is not clipped, and see the highest frequency content of your signal. Next class I will show you using this software how to see the highest frequency content of the signal, all those kind of things, and see the how much size it is taken. Then think about that, if I told you cut a window of this sample, this number sample to this number sample, how do you do that in a programming, also very important. So, those things you just practice. Okay? Thank you.